Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, now we see the problems of continuity, which is very difficult as compared to previous problem. In this problem, we have to check whether the given function is continuous or not at the indicated point. The question is f of x is equal to x plus 3x square plus 5x cube plus plus 2n minus 1 bracket complete into x raised n minus n square and whole thing divided by x minus 1 comma x not equal to 1 is equal to n into n plus 1 into 4n minus 1 whole thing divided by 6 comma x equal to 1. Now in this question we have to discuss whether this function f of x is continuous or not at indicated point x equal to 1. Now let's see the solution. First of all, for n square we write 1 plus 3 plus 5 plus plus 2n minus 1. So first of all, let's prove this. To prove 1 plus 3 plus 5 up to 2n minus 1 that equal to n square. Let Sn is equal to 1 plus 3 plus 5 up to 2n minus 1. So this can be written in summation notation as summation 2r minus 1 r takes value 1 to n, and that on further simplifying we have 2 times summation r takes value 1 to n minus we write summation 1 r takes value 1 to n. So that equal to 2 into, now summation r given as n into n plus 1 upon 2, then minus, and summation 1 for r equal to 1 to n gives n. So that equal to, now here we cancel 2 from numerator and denominator, and on simplifying further, that is n into n gives n square plus n into 1 that is n, and minus n we write as it is. Now here we again cancel plus n and minus n, so that equal to finally we get n square. So in this way we prove that 1 plus 3 plus 5 plus up to 2n minus 1, so that equivalent to n square. So in this question we have to discuss the function is continuous or not at point x equal to 1. So first of all, we start with given f of x is equal to n into n plus 1 into 4n minus 1 whole thing divided by 6, comma x equal to 0. It means whenever x we have to put 1, and therefore f of 1 is equal to n into n plus 1 into 4n minus 1 and whole thing divided by 6. Let us this denote as a equation 1. Now we consider the second part of a question. The second part is limit x tends to 1 f of x is equal to limit x tends to 1. Now x tends to 1 means x not equal to 1, and for that purpose in the question for x not equal to 1 we have given f of x is equal to x plus 3x square plus 5x cube plus dot dot plus 2n minus 1 into x raised n minus n square whole thing divided by x minus 1. So that equal to limit x tends to 1 x plus 3x square plus 5x cube plus going on plus 2n minus 1 into x raised n. So this term we write in one bracket. Then minus. Now for n square, just we prove that 1 plus 3 plus 5 plus dot dot up to plus 2n minus 1. And finally, the whole thing is divided by x minus 1. That equal to limit x tends to 1. Now here we take one term from first bracket and one term for second bracket. So we have limit x tends to 1 x minus 1 whole thing divided by x minus 1 as a one limit. Then plus we have limit x tends to 1, we write second term that 3x square from first bracket and then minus second term that is a 3 from second bracket and whole thing divided by x minus 1. Then plus limit x tends to 1. Now we consider third term that is 5x cube from first bracket minus phi from second bracket whole thing divided by x minus 1 and plus going in this way, and finally plus the last term is 2n minus 1 into x raised n minus, and the last term in second bracket is 2n minus 1 whole thing divided by x minus 1 as limit x tends to 1. So that equal to limit x tends to 1. Now for first part we cancel x minus 1 from numerator and denominator. So we get answer 1. Then plus limit x tends to 1. From second part we take 3 common. So outside the limit we write 3, and inside the bracket we have x square minus 1 upon x minus 1. Then plus from third limit we take phi common. So phi in bracket limit x tends to 1 x cube minus 1 upon x minus 1 bracket complete, plus now going in this way, so dot dot plus finally from last bracket we take 2n minus 1 common, limit x tends to 1, in the bracket we have x raised n minus 1 upon x minus 1. Now here we use one basic rule of limits, that limit x tends to a, x raised n minus a raised n upon x minus a is equal to n into a raised n minus 1. And this result is a true for all n belongs to set of natural number. So the next step is equal to, now limit x tends to 1 1, so that gives us 1, then plus we write 3 as it is into. Now the second part we can be written as limit x tends to 1 x square minus 1 square upon x minus 1 plus phi into limit x tends to 1 x cube minus 1 cube upon x minus 1 plus going on, and plus 2n minus 1 into limit x tends to 1 x raised n minus 1 raised n upon x minus 1. Now here we arrange the given question in perfectly formula which is just stated above, that limit x tends to a x raised n minus a raised n upon x minus a, and that equal to n into a raised n minus 1, and result is a true for all n belongs to set of natural number. So that equal to, we write first as it is, then plus 3 into Now x square minus 1 upon x minus 1 as a limit x tends to 1. So that gives answer 2 into 1 raised 1. Then plus 5 into limit x tends to 1 x cube minus 1 cube upon x minus 1. So that gives 3 into 1 raised 2 plus going on and finally plus 2n minus 1 into n raise 1 raise n minus 1. So that equal to 1 plus 3 into 2 plus 5 into 3 plus going on and plus 2n minus 1 into n. So this can be written in summation notation as summation 2r minus 1 into r as r takes value 1 to n, and this is equal to summation r takes value 1 to n. Now 2r into r, so that gives 2r square minus 1 into r, that is minus r. Now here operating summation notation separately for each function. So the next step will be we take two constant term outside the summation notation into summation r takes value 1 to n r square, then minus summation r that takes value 1 to n. Now here we use two formula for summation. The first formula is summation r takes value 1 to n. So that equal to n into n plus 1 upon 2. And the second formula is summation r square r take value 1 to n. So that equal to n into n plus 1 into 2n plus 1 and a whole thing divided by 6. So the next step of our question is equal to 2 into, now for summation r square we substitute n into n plus 1 into 2n plus 1 whole thing divided by 6, and then minus for summation r we write n into n plus 1 upon 2. Now from these two terms we take n into n plus 1 upon 2 common. So the next step will be n into n plus 1 upon 2. So that equal to 2n plus 1 multiply by 2 and divide by 3 minus 1. So that equal to n into n plus 1 upon 2. Now in bracket we go for cross multiply. So that gives us 2 into 2n plus 1 into 1. So that we get 2 into 2n plus 1 minus 3 upon 3. So that equal to, we write n n plus 1 upon 2 as it is. Then in the second bracket, if we go for simplifying, that 2 into 2n, so that gives 4n plus 2 into 1, that is 2 minus 3 upon 3. So in this way we get n into n plus 1 into 4n minus 1 whole thing divided by 2 into 3 gives, so 2 into 3 gives 6. So in this way we get limit x tends to 1, f of x is equal to n into n plus 1 into 4n minus 1 upon 6. So let us denote this as a statement 2. So from equation 1 and 2 we conclude that limit x tends to 1 f of x is equal to f1, and therefore f of x is continuous at x equal to 1. So this is a required solution for the given problem. Thank you.